Hi guys, I'm using a new app on my iPad to make this recording, so be patient with me if I mess it up at all. This recording is about the basics of the periodic table. You will be going into the periodic table more later, including trends and electron configuration and so on. Today we just want to get the basics down so that if you look at a periodic table, you can read it. The first thing that I have circled down at number 83, let's look down there at bismuth. The first thing that I've circled there is called the atomic number. And the atomic number is equal to the number of protons. See there, I started moving a little fast. I'll get it figured out. The atomic number is equal to the number of protons, which you should have learned about today. It's always equal to the number of protons. Now in neutral atoms, it's also equal to the number of electrons, but we can never tell just by looking at the number of protons if we're working with an atom or an ion. So all you really need to know is that that little number, that's the defining characteristic of an atom, because if I have 83 protons, then I must be working with bismuth. Okay, I could have more or less electrons and still be working with bismuth, but I can't have more or less protons and still be working with that. So you can see that the next thing that I circled there in green, that is the average atomic mass, and that's another thing that you also learned about today. Okay, the average atomic mass. This gives you a general idea of the number of protons and neutrons that are in the atom, but if you notice that that number is almost always not an even number, that's because it's average atomic mass, which is different than the mass number. Remember that the mass number is the number of protons plus the number of neutrons in a single atom. Okay, the next thing that we have to look at is metals, nonmetals, and metalloids. I have put in your Dropbox folder a blank copy of the periodic table, and you might want to write some of these things down. You'll be using your periodic table throughout the semester anyway, so it would be good to have one. And so if you just get out maybe some colored pencils or even just your pencil and do some shading, it will be important to know some of these things. There's a decent section on the midterm that covers just basic periodic table stuff. So what I'm drawing here in red is the staircase. Okay, again, everything in red is called the staircase. Notice that it starts at boron and goes down, over, and so on. That staircase tells us whether something is a metal or a nonmetal. Everything to the left of the staircase is everything to the left of the staircase is a metal. Everything to the right of the staircase is a nonmetal. Everything that lies on the staircase is a metalloid. And if you've noticed, I've highlighted those in yellow. Okay, so again, one more time, this is something that you definitely have to know. Everything to the left of the staircase is a metal. Everything to the right of the staircase is a nonmetal. And everything that lies on the staircase is a metalloid. Now, what a metalloid is it is a substance that can act both as a metal or a nonmetal, depending on what it's bonding with. And you'll learn more about that when you get to the bonding section. Now, one thing that probably pops out to you right away is that when I went through and did that highlighting, I didn't highlight aluminum. There are two exceptions. Oops, sorry, hold on one second. I'm already moving on to my other periodic table. Let's stick on this one real quick. There are two exceptions. The first is aluminum. Aluminum, even though it lies on the staircase, which means that it should act as a metalloid, aluminum is always a metal, okay, even though it lies on the staircase. The other exception, as you can see up there on the left, is hydrogen. You should be familiar enough with hydrogen as a substance to know that it is not a metal. It is actually a nonmetal. Okay, for other reasons, hydrogen is put over there on the periodic table because of its number of valence electrons, but really it could fit on the other side because it is a non-metal. So again, an important thing, everything to the left of the staircase is a metal, everything to the right is a non-metal, everything that lies on the staircase is a metalloid. Aluminum is an exception because it's always a metal. Hydrogen is an exception because it's always a nonmetal. The other thing that I circled down there, if you notice, down with the lanthanide and actinide series, I just wanted to point out to you where they fit in the periodic table, which would be to the left of the staircase, so you know that they are metals. Okay, switching over to our next periodic table. Okay, it's the same thing, I've just copied it again. And in this one we need to look at some of the vocabulary. The first thing that I'm writing out here, I'm going to see if I can get to move a little bit faster. The first thing that I'm writing out here is that everything that goes up and down, that's a group, also known as a column. Okay, groups and column. Everything that goes across is a period, or also known as a row. So for example, hydrogen, lithium, sodium, potassium, rubidium, and so on. So these right here, those are in a group. Okay, or they're also known as a column. Everything in, I can't seem to pick a new color here. Here we go. Everything that goes across like this, that's a period or a row. It is very important for you to understand the similarities in groups and columns. Okay, that shows up more than one place on your midterm. Everything in the same group or the same column has the same charge. Okay, it also has the same chemical properties, and it also has the same number of valence electrons. Now, valence electrons you guys probably haven't quite hit yet, but the reason that everything in the same group has the same chemical properties is because they have the same number of valence electrons. Valence electrons allow something to react or bond the way that it does. And so if you have the same number of valence electrons, then you'll have the same chemical properties. Okay, so again, everything in this group here, so something like this group, which is called the halogens, everything in the halogens has the same chemical properties. They react with things in a very similar fashion. What I started to do next here is I started to number the groups. When we number the groups, we typically just number the main group elements. What that means is that we kind of ignore everything in the middle here. Okay, those are called transition metals, and they react a little bit differently than everything else. Okay, but everything in main group elements, we look at those because they react in a very standard fashion. So if we number through there, we will go 1 through 8. What is very important about 1 through 8 is those are the number of valence electrons. Okay, so everything in this group here, okay, everything, hold on, let me get a new color again. Everything in this group here has 1 valence electron. Everything here has 2, 3, 4, 5, and so on. Okay, that is very important that you know that those are the number of valence electrons. When you get to bonding, you will have to know that. The next thing that I write on the top of each of those groups is its charge. And I don't want to go into how the charge is made or what it means because you will do that when we do bonding. Okay, you'll have to look at that then. But again, you need to be able to look at a periodic table and recognize that everything in that group has a +1 charge, everything in this has a +2, +3, plus or minus 4, -3, -2, -1, 0. Again, when we get to bonding, we'll review that and we'll go over why those columns or groups have the charges that they do. So again, real quick before we move on to the next periodic table, the last one, it is very important that you know that this whole section up here, oops, right there, okay, everything in the same group or the same column has the same chemical properties and the same number of valence electrons. Again, that will show up more than once on your midterm. The last periodic table that you need to be familiar with is the one where we are looking at the blocks. There are 4 blocks on the periodic table. Again, I told you that this is just an introduction to the periodic table. The next topic that you will cover after atomic theory, which is what you did today, will be quantum theory, which is where we'll start to look at electron configuration. Okay, and in quantum theory, it's very important that we look at the blocks. Again, there are 1 or 2 easy questions on your midterm where you have to pick out the correct block for a certain element. So one thing that you have to know before we get started is that the periodic table is just a tool. There are a lot of different ways to use a periodic table. We just happen to use the one that looks like the one that you see because it's just the one that has been accepted in the scientific community. Okay, there's plenty others that could work, but you kind of have to choose one in order for it to be standard across, again, the scientific community. So what happens is that we look at helium as over there near hydrogen when we're talking about blocks. And technically, helium could fit over there because, like we said before, everything in this group has 1 valence electron, everything in this group has 2, and helium only has 2 total electrons as an atom. So it does fit there. Now technically everything over here has 8 valence electrons, but helium is also stable and unreactive just like the rest of these. So you can see that there's a few things that don't quite fit exactly where in whatever place they are because they would fit in a few different places. So for what we're doing, helium for the blocks, helium is considered over there near hydrogen, which is where I drew it. The 4 blocks that you need to know are outlined in red. There is the S block. Outlined in blue are your transition metals. That's the D block. In green is the P block. And down there in the bottom is the F block. Okay, it's important that you know those blocks. So going back through what you need to know if we go back to the beginning here, you need to know that that number is the atomic number. You need to know about the average atomic mass. This is a really big one, is to know that everything to the left of the staircase is a metal, everything to the right is a nonmetal, everything that lies on the staircase is a metalloid. Aluminum is always a metal, hydrogen is always a nonmetal. On this one, it's very important for you to know that the valence electrons go 1 through 8, and that the charges go +1, +2, +3, plus or minus 4, -3, -2, -1, 0. It's also important for you to know that everything in the same group has the same chemical properties and same number of valence electrons. Finally, the last thing that we covered is the blocks. You need to know these 4 blocks.